which is a little bit unfortunate. So we'll see. I don't know. Maybe I'll put it up. But for now, just for me. Let's see. Oh, I gotta move some desktops around here. Logistics. There we go. All right. So this is for TS circuit. If you don't know TS circuit, what it does is it makes it possible to create circuits in React, and then you can use an AI to use natural language to generate these circuits. So it's pretty cool. Yeah. So for today, we're working on auto layout of the schematic view. So you can see in this example, we set the center. So that's why this is at 0, 0. It's because we set the center of this component, which is called a bug. And then the resistor is set at x equals 2. So if we zoom in here, should be at, yeah, it's at x2, y negative 0.5. So, and the ground symbol is upside down for some reason. That was something on the list. I do have a list of things to fix, but I flipped to the coordinate axis and it made a lot of symbols look weird. But anyway, so today the goal is to get auto layout working in a better way, or more automatically. So you could not specify this. So currently you don't specify it. It's going to put everything at 0, 0. But we want it so that things lay out in a somewhat natural way. So that's the goal. Let's move some stuff around. More logistics. Yeah, cool. Okay, and let me get my chat up too. While that's going on, pull up the terminal and let's do some stuff. So the only thing I've done is I set up some annoying parts of this project that would have taken a little bit of time on stream to do. So I basically just set up this project so that there's a playground and there's boxes and ports. So we're going to use this storybook to develop our algorithm. So we'll test out the algorithm in a bunch of stories or scenarios, and then we'll eventually deploy it to the project. So let's see. Cool. All right. I now have a chat accessible. Cool. Okay. So yeah, let's jump right in. There are 3 types of layouts we're working on. So row layout, column layout, and then what I call central LR, which is a central bug. And if we look at a tweet I did, we can kind of see what this is supposed to look like. So this is a pretty typical schematic symbol. This one only has left side ports, but that's fine. That is also covered by the model. This one has both left and right side ports. And the goal is to come up with an algorithm that automatically lays these things out. There's a second part to this algorithm. If we go to the repository, that should move things down to align them. So I suspect that this will work. And what we'll try to do is recreate these 2 schematics exactly. And if we're able to recreate them and it looks okay, then we're good to go. We're definitely not trying to recreate it exactly. This one has a lot of rotated capacitors, and I don't think we'll be able to do that. So I think everything except that I think we can do. So let's jump in. There's a couple ways to do this. Before we even start in the algorithm, what I want to do is recreate this schematic. I think that'll be good in our sort of domain data structure. So I'll create a new story. A story in Storybook is how you draw anything. So we're going to create a new story. We're going to call it bug1.stories.tsx. I'm not a huge fan of the dual meaning of bug, but you know, I don't know what else to do. I don't know a better word. Let's center it at 0. I feel like that'll make life easier. We're going to say right ports is 0, and left ports we're going to say is 1, 2, 3, 4, 5, 6, 7. So we're going to have 7 ports on the left. And then so this is our main bug. We can look at this as we draw it out too, so that might make life more fun. Actually, let's see. Maybe I can do something fun with the view here. I'm gonna move this terminal out temporarily. I'll split vertically, and then we'll have the story that we're creating. So that's the beginning of the story we're creating over here. And then I'll have the tweet down here. And so maybe that'll make it a bit easier to recreate this. So on the right, I'm going to be updating the scene definition to look like this. I already see an issue where this doesn't expand out all the way. I think it's because of how I did the port stuff. Yeah. So some bug in how I designed this. It's kind of interesting. Let me fix that before we get too started. That's a good, easy bug to get started with. So I think in the scene builder, yellow, have you seen SNL Papyrus 2? Yeah, I saw it. Classic. That guy's the bomb. Ryan Gosling, I think. Guy's the bomb. Absolutely. Yeah, Papyrus is such a classic sketch. I will say, I think with SNL, the number 2s are never hit as hard as the number 1s. I'm not sure there's a number 2 that has ever hit as hard. That's pretty good. Where is the box width determined? That's what I'm trying to figure out. Have you given up on Viz Network? No, so yesterday after... actually, yeah, no, I have. Or no. Okay, so basically this is what happened. This is what went down. Yesterday, I made progress on it. A lot of progress. Like, I think basically understood about how well the technique would work. And then I was like, I started just looking at schematics, and I was like, yeah, so I think I'm trying to remember. Autopack, that's what I called it. Let's see if we can pull this up really quick. But I think it's good for how you organize subcircuits. So I was looking at it, and it wasn't... It never seemed like you can flip that. It seemed like I was going to do a lot of heuristic algorithms to align things. And there would be so many heuristic algorithms to align things to get things to like appear in columns and stuff like that. This one is actually pretty close. So you see C1 is above R1, right? That's good. R2 is kind of down here. It's not bad. It's not a bad choice. So like it actually, this one's not bad, all things considered. Like, you flip this around. So anyway, it's like, it's pretty good, but when you look at, it's okay. But when you look at, I mean, I don't know, it's all an experiment. What I might find out is that it's a good component algorithm. But what I really think I discovered is, like, when you look at the schematics, it's almost always one of these major bugs, and then a bunch of other connections and nets going out and stuff like that. They almost all have this organization structure. Sometimes they even separate this into a grid. So I was like, okay. So I think the better thing to do is this is where you run the packing algorithm to organize all these subcircuits, and then you do heuristics for the subcircuits. Because the heuristic I'm doing right now is basically this one where you stack up the components vertically, and then in a post-processing step you make them even. So I think it's a very simple algorithm, and that'll be beneficial because people will be able to understand it. Oh yeah, that was the other thing with the packing thing, is I'm not sure how much people understand it. I think if you pack things into a grid, do some kind of square packing, people will understand it relatively well. But all of these but most of these subcircuits do follow the format of, like, I think the heuristic algorithm we're going to build today, with the exception of maybe this one. This one has two kind of joined subcircuits. So, but you could come up with a heuristic for this too. You could say, oh, there's two bugs. One's a smaller bug. You could literally just apply these heuristics, and then people can opt in explicitly to it, or the algorithm will figure it out, because it does seem like there's only so many ways to organize the circuit. But this is the one we're kind of trying to do today, where you stack upward. I don't know how this one's going to go. I think in my version of it, it's going to be a lot wider, because I don't think I'm going to rotate anything. This has a lot of rotations. Yeah, simplest is better, I think. You could get really fancy with the LLM and stuff like that, but at the end of the day, I don't want LLMs to solve, like, LLMs for web don't solve X and Y problems. So I think it's not a good idea to have them solve too much. So we want to remove as much complexity from that part of the solver, which ironically means we have to do very, very conventional software layout work. Like this is like the least fancy thing I can think of is a heuristic algorithm that lays out schematics conventionally. It's like, it's nothing. Okay, so let's fix this quick visual bug where this box does not expand out to the ports. I'm almost positive I know why this is happening. It's because of how the width is calculated. So you've got these boxes. Just remembering how all this works. You've got a scene. I don't think the width is part of the scene for whatever reason. Maybe it should be, but I think it's computed somewhere. Yeah, there we go. It's computed here, and it does max x minus min x. So it's centering the box, but this isn't like, yeah, it's kind of a dumb algorithm. A really dumb way to fix it for now is to do absolute value max x. So you do the maximum of these two absolute values. Whoops. And you multiply it by 2. So as long as it's symmetric, this will fix the problem. It's a dumb solution, but it does fix it. Probably regret that later, but this drawing library is just to debug algorithms. So a bug like that, not going to be super important. Let's rename this. Call it bug 1. Okay. Oh, whoops. Confusing myself. Bug 1. Okay, there we go. Okay, cool. What do we need? So these are connected to ground here. Ground net aliases are interesting. They're represented by a component. So I think we need to represent that. Let's do this. Nice. Okay. Oh, I think some of my ceiling is cutting in. Cool. I can cut that. Perfect. Perfect. Very cool. Yeah, I have the world's least controlled lighting, so. So we do have to add that ground as its own kind of container. So let's do that. Add CCW box, add LR box. And then we'll say add, I don't know what to call this. Add top box. It's kind of a dumb name. I'll take it. The X and Y positions that you give these are just like setup. So they're not going to be used. They're used for drawing it to this playground, but then we're going to recompute it as part of our layout. But it's really nice just to have the initial positions laid out. So like you're like, okay, where does the algorithm take this? And normally initial conditions matter, like for the packing problems and stuff like that. But in this case, we're gonna reset everything before we do the packing, so it should be fine. Rx, Ry, okay, let's add it. So we're gonna say add T box, and we'll call this ground 1. There's gonna be a lot of grounds, which is fine. That's normal. In the we'll set -1, and then y0, sure. No. Y would be -3 or something. I forgot to return this. You're gonna allow people to put their parts and press a button to connect them. So, oh, this is drawing weird now. What is this supposed to look like? Like a single port. I didn't think about this case. Let's see. Yeah, people will basically put their parts in, and then how they're connected is via trace in the playground. So these things down here, but this is kind of the low level way of connecting them. There's a lot of other ways that parts can be connected. But it turns out the LLM is very good at doing it this way. It understands the sub language, which is like CSS and stuff like that. So this works. But there'll be other ways to connect your parts later. For example, if a part has VCC and ground, which is very common, power and ground, then you can connect those automatically. So that was part of the original point of TS circuit and like React for circuits was like, hey, can we connect a lot of stuff automatically? I'm not super concerned about automatic connections right now because it's funny how LLMs change the game, but if the LLM is writing out a lot of the circuit for you, like it's not that tedious anymore to write those connections, and like you're less likely to forget. Plus, with static analysis, so what happens in the AI stuff, which I probably won't do this morning, I might do later today. Maybe. It depends how quick this goes. But the LLM actually gets the result of a static analysis. It gets the result of a type check. It also gets the result of an actual trace analysis and stuff like that. So if a port is disconnected and it has to be connected for a chip to function, that can surface as an error that's super readable that the LLM can then use to correct. So automatic connections are not that big of a deal anymore, relatively, because the LLM gets errors and then it corrects them and all this. So it's like kind of not clear if improving the developer experience with automatic connections is that important. And people, I mean, there's plenty of ways to do it in user land. Like I don't have to build it in as a low level thing. I think in user land they could absolutely do automatic connections if they wanted to. But it doesn't seem super important as the author, as the library author. Let's make this box render better. So in the playground scene where it figures out all the boxes. I can use the same I think this will work. I can use the same technique for the height. So max y, min y. Okay, so that made the height go out more. I think we can remove this. And then I'm going to add as a parameter to both of these 0.1. Because the intent of that 0.2 was just to give it a minimum width, I think. Oh, I guess it was to extend it outside the border, but that's fine. This is really tall now because this is like a symmetric constraint. I think I can... This is such a dumb way of doing it. You know, every way you architect your problem, you're going to have some dumb issue. And I didn't think about this one very long. But anyway, we can reduce this by doing like a lower number here. Yeah, okay. Does that look like ground? Looks like ground enough for me. Yeah, okay, so that's a ground connection. Actually, I would like it if it was more square. Yeah, okay, so that's a ground connection. Okay, this is a really early break, but I gotta go to the bathroom. 5-minute timer. All right. All right, let's do it. Okay, we got our ground. We also have to draw out the connections, which I think... Oh, the connections aren't drawn yet? I didn't do connection drawing. Okay, let's go back to the basic story And let's get that connection drawing working, because that's pretty important. Oh, I should shut my door here. Okay. There we go. So this connects to nothing. Let's comment that out. Let's go to basic. So we're trying to connect A to B, one of these ports, A.1 to B.left. So that's that to that. They're kind of backwards to make that connection good. There we go. So all we want to do is draw a line. So we'll do, scene dot connections. So it gave me a line there, but we have to do some transforms and stuff. So I'm going to say box connection from this to this. We're going to just do that type of keying. We'll create a class box connection.tsx. And then if we go to attachable box, it's got a lot of good stuff in here. I think the main thing I want is that use playground context. Yeah. Okay. Box connection. Pull out the transform. HTML doesn't have a line component. When you want to do a line, you kind of have to do an SVG. So you have to create an SVG container for that line. So it's pretty annoying. There's no way to do a line. It's sometimes nice to draw everything with lines to a canvas. Yo, what up, Darwin? How's it going? If you draw lines to a canvas, you have a lot less to worry about. So we could do that here, where we say like lines canvas. The main downside of that is, I don't know, it gets blurry if you zoom in. It's so much easier than doing SVG. You have to create so many SVGs for the lines. I don't know. I'll do the SVG approach, but it sucks and I hate it. So we'll go to box connection. We have our transform. We'll need that. We'll also need the apply to point method from transformation matrix, so that'll apply our transform. So this is an affine transformation matrix. So it's got 6 numbers, A through F. So basically implementing this tweet on the bottom left is what we're doing. So this is a schematic layout, and we're trying to make it so that it goes automatically. So building an algorithm that does that layout automatically. And the reason we're doing that is so that when we create schematics via AI, it doesn't put things in the right place. So if we do it automatically for the AI, it'll make the AI look a lot smarter. it'll make its content more readable. There's a lot of ways to solve the problem. This is just one. I think this is a hard way, but possibly the most effective. You know what? I'm going to switch to a canvas because I just realized that it's going to be slightly more work than I thought. So we'll say lines canvas, and we're going to pass in the entire scene because we actually do need the boxes for it. That's why I realized it was like, you know, since you need global objects anyway, because the connection format, it only has it has from and to, and so you have to search the boxes to figure out where that from and to are, and you have to run a transformation on each point. So it's kind of annoying. Let's import that type for scene. we're going to return a canvas object. Canvases can be annoying because you need to give them a width and height, and usually you want them to take the width and height of their parent, but it's not always super easy to get that. I think, yeah, there's so much logistic stuff with drawing a line in HTML. It's pretty annoying. I think what I want to do, I guess I'll be really lazy just to start. It's set statically to 1000, 1000. So just to get us started, I'll be really, really lazy, but I could use a ref and then get bounding client, whatever, to do it a little bit faster if I wanted to. Okay, so width 1000, height 1000. And then we'll create this canvas ref using React's useRef. It's good to give it a type, HTML canvas element. And then it can be null. It's initially null. So we'll do that. Need to import useRef. Let's see. Yeah, so what React is suggesting, hey, if the canvas is defined, you probably want to draw to it. So it's giving us a way to do that, or what Copilot is suggesting. This is an okay technique. It's technically a little bit slow. We can start with it. And then how you make it better is you call useEffect. It's kind of fine either way, especially for this application. It's just a debug UI, but this is technically a little bit of a better way to do it. If not, canvas ref return. That's just good practice. Okay, and then it's drawing a line for us. That's actually fine, just to test it, make sure the canvas goes somewhere. And then, did I put this in the wrong file? I'm losing track. Okay, there we go. Box connection we're no longer using. We'll delete that file. And then this looks good except for the name. Lines canvas. Then we'll go back to our playground. Or no, not our playground. Playground scene. Man, I gotta stop naming things like this. I have to stop doing this. All right. Yeah, it doesn't take scene, but it should render now. Okay, cool. So we should be seeing a line. I don't see a line anywhere, though. Let's see what's going on. Stroke. I noticed it didn't set a stroke style, so that could definitely be part of the problem. Set the stroke style to black. I still don't see anything. Maybe it rendered, yeah, it rendered below it. So not a problem. Let's just set a style on this guy and make it render. It's in a relative container, so we can just say position absolute, left 0, top 0, and that should render out. So when you go from HTML land to like graphics programming land, I'm not like an expert. I don't consider myself an expert on like anything. So, you know, a lot of BS. But in my view, when you do graphics programming, when you move from like regular HTML programming to graphics programming, a lot of people are really timid about transformations and they try to make things contain other things. So you're going to say like, oh, the tooltip is relative to the box. And that makes a lot of sense for web programming. But for graphics programming, that's really, really difficult. And you really want to get all of your coordinates in your projected space and then transform them back into screen space. And so you always want to be, you don't want to say, oh, this is left of this or anything like that. You really like, left 0, left 50 or pattern, all this. You want to avoid that. And for the most part, just keep 2 coordinate systems. You know, whenever you see X, that should be in absolute position in either of the coordinate systems. I didn't totally respect that principle here, but I respect it enough where this should be really easy to draw this line, and it shouldn't be a problem that we have a canvas over here and then SVGs over here and all of this. Like, it shouldn't matter because they all project properly to the space. I think when I got started, I did a lot of things relative to each other, and it made it really difficult to say, oh, I'm going to have a random canvas over here, do this totally different thing, and somehow map to the same position, right? But it should be easy because we're using these transforms properly. So with that, let's draw the lines. So line canvas takes the scene. We're going to go through each connection of the scene. For each connection, there's going to be a point A, point B. So connection dot from. Okay, so the connection syntax, I forgot about this. The connection syntax is a little weird. So we're going to have a subfunction to do it. It's box dot port number or something like that. So we'll say find, we'll define a function, find port, and it will take a selector and return port ID string. Actually, we really only care about the X and Y, so it's a little bit, it's not a great named function, but that's good enough. And that's it. It wrote it for us. If not box, yeah. If not port, yeah. Apply to point. Okay, so when you have, so this last part's wrong, but it's a really good, yeah. So it's a really good example of how you can easily get confused with coordinate spaces. So is this screen X or screen Y, right? What it's returning. Whenever I return something in the screen coordinate space, I like to prefix it with screen. And then for the other coordinate space, I sometimes call that the projected space or something like that, but it's often confusing. And since the user, there's a principle I call variable transparency, where you want to keep a variable name very consistent as you go deeper and deeper into your code. It's really nice if the variable can stay consistent. For that, you need really well-named variables. I think X and Y is really hard to be clear as it goes down, but it's also what the customer or the user specifies their circuit as. And so I usually use X and Y. This is all to say, I usually use X and Y to refer to like the space of the schematic or the space of the PCB or something like that. Yeah. So screen X, screen Y. To return this, we need to project a new point. So we'll say port position equals, this is where there's some jank. Why is this? I'm getting some like weird indentation stuff here. Speaking of screen, by choice or didn't notice, I did select that in that crazy stream resolution. I don't know why. Is it? So is it actually noticeable? I do have 4K resolution. This is so what I do, I don't know if I can show this. Yeah, it won't show, but I have a 4K monitor. They won't give you max, probably 1080. I'll probably switch it to 1080 after this. I didn't know people noticed really, but yeah, that's interesting. I wanted to do more than 720p, but yeah. Anyway, what I do with my 4K is I use Linux to split it up into multiple virtual monitors, and so I have, so from my operating, like, I don't know, it's kind of a weird thing, but like from my perspective, I have multiple monitors even though I only have one monitor. So even the resolution of like this subscreen we're looking at is some crazy thing that doesn't make sense. I think I run a script called setup live stream, and it sets up 2 virtual monitors right now. Yeah, and it's this crazy resolution, 2881 by 1620. Yeah, and then the monitor on my left is like super long. It's great for chat. Um, yeah. But yeah, I should probably revise it. I might also, I have a second computer, a little tiny, like, do nothing computer, and I have a capture card. So I could theoretically, like, try to take some load off the main machine, but I don't know. It's like you mess around with this stuff and it's fun. It's like fun to figure out how to optimize this, but it doesn't, I don't think it matters. Like, people stream from their phones. And honestly, if I like mounted my iPhone here, it'd probably be a better camera. So, what is the job of a window manager? You are doing it with virtual screens. Yeah, exactly. Yeah, it's a really cool feature of, like, I guess i3 is what I use. That they can simulate multiple monitors, and it works super well. It's actually a hidden feature of i3. They call it like a test only feature, but it works perfect. I've never had an issue. I have no idea why it's not like something that is more advertised. It's super cool, because like all the people are really worried about sharing passwords and stuff like that, and OBS only has access to like one monitor, so like even though it's on the same screen, you can't. It's really hard to accidentally show something. Anyway, I don't know. Just fanboying about i3 a little bit. Okay, so we're gonna apply the transform to the port position. This is where I kind of broke the rule about relative coordinates. I just didn't. I don't know. This is all a debug library, so. Okay, so we return apply to point. It's upset about this. I might have gotten the signature wrong. No, matrix and then point should work. Port position. I have 3 physical monitors. I only use 2. I like my screens. I used to really like it, but it's kind of like, it's really psychological for me. Like the more cluttered my space is, it can take away from my focus. It really depends. If I'm like, it's kind of funny. I don't know. You spend your life figuring yourself out, but if I'm like super into something, super into it, then I can have my life can be a wreck around me. There can be like rotting food on the floor, and it won't matter. I'll go crazy, and I'll go like all night, like crazy energy and stuff like that. But when I'm doing like a slog, and hey, B2B SaaS, it's a lot of slog, it's a lot of glue. I need it to all be clean, and like I just need to, like, because anything that will distract me can. And 2 screens always tempts me to have something up on the other screen. I don't like it to be empty. And so when I have sometimes I'll literally just zoom in like this. I'll bring up the font size and I'll be like, you got to focus. You got to do this bad thing, or dumb thing. You got to build this integration to Salesforce. Yeah. I mean, I'm probably on one of them. Like doing the distracting. But I do the same thing. So like complete I have a phone mount, and I can like a car phone mount, and it goes right next to my monitor. So that's how I do live stream. And that way, like, I'm usually not looking too much at the video. And it's mostly an audio stream. But whatever works for people. I've coded to live streams and YouTube videos on the side, especially when something's a slog. And sometimes I think your code is worse when you're super distracted, but I think it is good to have code bases that you can program distracted in. I think that's a sign of a good code base. And so alternating between that kind of focus and then being able to work in it, because for me, it's like, oh, if a code base gets too complicated, I'll be like trying to do something in the background, then I'll get frustrated, and then I'll turn it off and I'll focus in, and I'll be like, okay, let's make this like not stupid, like not hard to work with. And so sometimes it can be a good balance. If you're always focused, some engineers, they're super good, and they can hold so much in their head that they write super complex code that nobody can understand, right? And it's not a good thing for working on a team. You might be able to pump out something really great, but it's not always the easiest to follow along and stuff like that. So yeah, I don't know. It's complicated. What a rant. Okay, So find port. I don't. Oh yeah, this is complaining. It's missing the following property: screen X, screen Y. Okay, so, I need to remap this. So we'll call this screen point. It's like very pedantic. It's like extra lines of code to do that, so it's a little bit pedantic. Okay, cool. So now we have our connection in screen space. We should be able to draw this. Let's try it. Yeah, the content that goes on the side of your screen, I think, is a whole super interesting category. Okay, so port not found 1. It was not able to find port 1. I think with resistors, it's like left and right, so that could be the issue. Let me see. Basic. B dot left. B dot left. Box.ports.find port ID equals port ID. I don't know. Let's log the box. Just take this one step at a time. But I think for content that goes on the side of your screen, it should have lower density, something that you tune out as you get focused. I think. But you know, in the case of like live stream programmers, there might be something there where it's still like having a colleague who you're programming next to or something like that. They're doing the same thing you want to be doing. It's possible, like, and I don't know, I'm just like speculating, but it's possible like watching video games or something makes people want to play, you know? And so if you're watching that while you work, it's maybe not the best content because it might make you want to play. You might be like, I really don't, I want to go. Or something like that. Or engage with it. Video games are engaging, so like you can engage with it more. So I don't know. I guess that's the argument for virtual co-working spaces. I haven't thought about it that much. I'm just here doing a thing. I don't really know what I'm doing yet. We'll find out. We're doing a startup. It's an adventure. Port not found 1. Okay. So, the port ID is actually fully inclusive of the name. I didn't know that. This is the mood. Firebringer. Classic. How have I not seen this? Firebringer. That's interesting. I don't know how important the audio was. I did have the audio off. I think I got the gist. So port ID audio is very important. Okay, let me see.
What? What's this? Uh-oh, I don't really want to do the work today. I don't really want to do the work today.
Well, that's kind of catchy. I like it. Quality. I'm gonna fix my green screen briefly here. I think it's like slightly blurring. Although like the answer is lighting. The answer is always lighting, but I just see it come in and out. Plus it's fun. It's just fun to mess with the setup. That's really what it comes down to. Oh, I don't want to fade myself though. Let's try this. So first we do this. Oops. First we do this. All right, let's see. I don't know. And then increase until I start to fade. Maybe? I think that's going to work pretty... Oh, no, I'm faded. Playing with OBS is just fun. It's really for me. And I show none of it. It's all off screen. All right, good enough. Cool. Is this working? Did I like give up early? Oh, yeah, the port ID is absolute. I don't know how I feel about that. So we're gonna do this. This is actually port ID. It's fine. Did I fix you? Yeah. Yeah. Yeah, that's pretty broken. The issue is this use effect needs to also run whenever there's a transform change. Okay, there we go. So now we have our canvas line being drawn, connecting these two things together. You know, I thought I had done this right with, but I guess I didn't. B dot right. Yeah, there we go. Okay. So yeah, this should be pretty good for debugging our algorithm. I really want to get this done today. If this doesn't get done, you can spend an eternity. People have written like PhDs, white papers on like Cassowary and other layout like engines. I don't know if Cassowary was actually made for layouts first, but anyway, yeah, people spend a lot of time on this stuff. So I don't want to spend too much time on it. Hopefully we get something that minimally works and then we move on with our lives. I kind of want these lines to be a different color though. Let's see. Stroke style. I think I can make it thicker like that. Does that work? Maybe? No? Stroke width, perhaps? Stroke width? Stroke. Line width. I feel like CSS properties are super randomly named. Let there be light. Overdone it a bit. I don't know about red. Let's do blue. Yeah, you know, it's got to be something you feel comfortable looking at a lot. Why? I thought I would be able to change. Forget the name of the. Oh, it's global alpha. It's so random, right? It's like opacity here, global alpha somewhere else. Okay. I feel pretty happy about that. I don't know. Maybe green. Do I want green? Let's do blue. I like it. Okay. Now we can build this guy on our bottom here. So we'll go to bug 1 and we will begin to build the long, arduous journey to building out this entire schematic. And it will be arduous. Lives will be lost. I'm going to do a very approximate version, then tweak it. Let's get all these ground ports out. -7. That's maybe too far spaced. 2. This one feels like it's not far enough. Let's do 2, 3, 4, 5. See how that looks. They're not exactly even, but that makes me pretty happy. 1.5. Let's do that as 4.5. 6. It's good enough for comedy. My favorite quote ever is from this guy. I forget his name, but he was in Scott Pilgrim versus the World, and he was like doing a stand-up act. And he was like, he's tuning his guitar, and he just stops and he goes, "It's good enough for comedy." Love it. Great quote. C12 kind of comes first as far as the ascending port order. That's why it's an ascending layout, call it. It's so weird how many reversals happen. There's like, it's going counterclockwise, so it goes down and then it goes up and then Y is up. It's all over the place. No consistency. I don't know where to put this. I also don't know if I want it to be rotated because we're not going to try to do rotations today. So I don't feel like there's a point in doing a rotation. Let's see how that goes. Okay, so definitely not the right or even a good Y position. Let's do 0.5. I do feel like capacitors should always be down. If you're going to pick a direction for them, it should always be down. That is an interesting sub-problem, though. I don't really know. So the sub-problem is you have a sub-circuit. Do you organize it to go row-wise or column-wise? I think you do organize it to grow by column, by default. Over here, they all seem vertical by default. I think that's good. I think that makes sense. There's an alternate version where instead of growing this box vertically, you would flip it. It would grow horizontally. But I think vertically makes a lot of sense. So let's flip all these resistors. So instead of LR box, we're going to call it a top bottom box. Oh. TB box. That's pretty confusing with TB also being a word, but you know. Okay, add top bottom box. This is a little bit of a hole in my naming conventions. I don't know if this should be TB, like top bottom. I think it's two separate words. I think it's TB. TB is not in. Yeah, it's a little awkward. It's separate words. Yeah, okay, but it's also an acronym. Yeah, it's a little confusing. It's a little edge case of the Google camel case convention or whatever it's called. I think it's I think it's Google that came up with consistent camel casing conventions. You know, actually, now that I think about it, it should be lowercase b, because if you did it in snake case, I'm pretty sure you would do TB. That's the easiest way to think about consistent camel casing is you put it in snake case and then you just capitalize basically according to that anything before or after a underscore. It does look weird though. LR CCW. Oh yeah, for CCW clockwise, counterclockwise. Yeah. So I used it there. Microsoft has a crazy convention, and they would capitalize these because they have special rules for things that are only 2 characters. So it sounds like so stupid to think about naming a ton, but it's actually super important because if you're designing APIs, a lot of people are going to type the wrong thing. It's a super substantial portion of time, and if you do it weird, you know, AI now will create typos if you're not careful. So I think it's super important to do the right thing. Okay, we'll do this. Switch these. 0, 0, negative 0.3 for the bottom. Looks a little weird to me, but I think it's right. Okay. Let's keep building it out. It would be really nice if these had labels too in the center. Is that going to take a microsecond to do? Playground scene. B dot box ID. Okay, so it aligns the top left, which I don't love. Let's try to get it center aligned. We can do that with display flex, justify content, center, align items, center. Maybe I should kind of go all in on ASMR programming. Hey. just commit to that as the bit. I don't really want to whisper into my mic too much, though. It's a little weird. Maybe it's like a Monday thing. All right, that's good enough. You can see a little bit of the symbol. I like how small it is, actually. It's not there for readability. It's there for debugging. Bug 1. C11. We'll put that slightly to the left. I'm trying to figure out how they do 2 adjacent grounds. I think the way they do it a little weird here. That's not normal. I think when you do 2 adjacent grounds, you actually do have 2 ground symbols. Maybe you connect it at the end. I'm going to have it connect at the end, but I think that would be dependent on how you specify the schematic. I just realized too, we probably don't want people to have to place these ground symbols, but that's a different problem. That's the net alias problem. So that's got to be solved too, but later. Usually only ground goes down. I think you never have anything but ground go down. Luckily, it's super common to pull something down to ground or have a decoupling capacitor. So it's very common. So it's worth building out. But it's literally only for grounds that you do this. The rest of the time, it needs to go out and do its thing, whatever it's got to do. So something to keep in mind. It's allowed to go up to power, down to ground, and nothing else conventionally. Unfortunately, there's almost nothing in this particular schematic that shows that. Whoops. I tried to sneak my notifs in. All right. Let's get another SparkFun schematic out. This is an old one. Yeah, this is pretty cool. This is hard to auto do. Tons and tons of pull-ups on this communication port. But this could be a heuristic style. You can identify these things and do it as a style, but yeah, pretty tough. Yeah, the net alias support is kind of lacking right now, which makes a lot of this stuff pretty annoying. Yeah, let's add that to the list. Net alias support. That's a pretty big item, but I don't think it'll be too bad. Oh. Okay. Net alias support. Or horizontal net alias support. Already support net aliases, but not horizontal ones. And the support is super weird. Doesn't connect up properly. I also just realized somebody was commenting. I think there might be an update on this GitHub issue. I have the latest version of TSX installed globally. Okay, so for this person, to the package JSON, I've updated the latest version of TSCI init to add it automatically, but you'd need to patch or install. But yeah, that's probably fine. Cool. Love bug reports. Oh, here's one going up. TP1. I guess this pull-up configuration is really common, at least in this case. So pull-ups are allowed to go up. Here it goes up too. I don't know. No. VUSB. So anytime it's got to be power if it's going up. Okay. I'm gonna keep these up because it's nice to have references. I think right now I just got to do this layout heuristic. I don't know what I'm gonna call it yet because I don't even think LR center bug is that good of. It's gonna need a lot of heuristics, and it's gonna take a while to discover what's kind of best. I think that looks about right. That's what I would expect. This one is centered to go down to ground. I think the Y position could be lower. Even lower. So the idea, I think I drew this a little bit weird, but the idea is this dotted box is actually centered around the U1. So so after you get the height of all of these things, you center them. Rather than try to align ports or something like that. You could try to align ports, but I think it's easier, simpler just to center, even if it makes some of the traces kind of wonky coming out. I don't think there's much you can do about that. These ones are pretty good at staying straight, but there's like little bits of overlap here. It's like that's pretty hard to do automatically. So people will write better versions of this too. I don't have to reinvent the wheel today. All right. Not done yet. Bat. So VBat goes to bat with this guy. I think I'm going to call this a component. Is that the next thing? Yeah, it's the very next thing. So add LR box bat. I don't trust any of these positions, but actually that looks okay. This one's going to be slightly higher. Let's just take a quick look. Yeah, we're going to go up by 1 each time. I think that's fine. So we have VBat. Oh, we should do in the connections too. So after C11, we'll do connect. One, two, three, four, five, six, 7. So U1 G3.7 to C11 dot top. Hopefully that works. Okay. Oh. Actually, it's 5. And this one is 4 to C12 dot top. Yeah, there we go. And then these both connect to ground. I forgot about that. What do we call the port ID? We call it top. Okay. G1.top. And same thing for 6. Whoops. Yeah. Okay. Yeah, it's starting to work. These both go to G2. Yeah. Or this should be C12. Okay. this playground grid doesn't automatically center, which is kind of annoying. But there is this translate built in that I can adjust. So if I do 0, the initial transform is pretty low. So let's do -3. And it's a little higher. Let's do -2. Okay, so that's perfect. So we'll just hack that for now. And maybe make that programmatic later. Okay, making progress. 1, 2, 3. So we have 3 maps to battery right. Close. Okay. And then that goes to, weirdly enough, back to VCC. So that is a good edge case. So battery left goes to U1. So we're hoping, without having these positions, that we can auto layout to something like this. So it's gonna be pretty nuts. I don't know. I hope it works. So, yep, this one's okay. So VCC USB. So let's add C6 and the gang. So add top bottom box C6. And going up in ascending order, this would be at 0 now. And then these ones also go up in ascending order, but they're drawn differently here, but it doesn't matter. They have to go like this for our version. So that's C5, C4, C3. And they're all connected to VCC. So, and then ascending order, that's 6, 7, 8, 9. 0, 1, 2, 3, 4. Okay. So yeah, that's kind of roughly what we're expecting the layout to be like. And then the same way that we bring everything down via this method, we can bring things up so that they're all symmetric with an identical version of this method. So lots of complexity. Who's mentioning me on Twitter? Oh, it's just people liking stuff. I would love to get in a Twitter debacle on stream. That would be perfect. Live reactions. Because then, you get into that virtuous kind of Twitter reaction, anger thing, but you do it live, which is great for stimulating engagement. But, I'm not a controversial character enough. I need to pick a side and then flip it weekly. I just care too much. I think about things I say for a pretty long time sometimes. And so, yeah, I don't know. But, you gotta thicken it. You gotta thicken that up if you want to be on the tweeters. All right, C5 bottom to G. I think this is the last G, so G4 dot top. It's going to be like this for C5, C4, C3, C2. So C5, okay, so C2, C3, C4, C2. Wait a second, oh yeah, C2, okay. Perfect. So these guys are all connected to that. And then they're connected to power, which is also connected to VCC. Yeah, it's a little weird because technically, yeah, actually, I think technically this battery connection wouldn't really be there. This is interesting. I think I know what I want to do. I think I want to create sort of, there's always going to be power aliases and ground aliases below that you can go to. And they're like virtual. And then we connect things as if they're connected directly to those aliases. The weird thing is there's so many grounds here, and then there's only one 3.3 volt here. And it's kind of hard to say if that's a stylistic choice or not. It seems like the convention is to have lots of grounds and maybe one. There's two here. Well, those are all different, so that's fine. Yeah, I mean, they're duplicated here. I think that's an unusual choice for this one. I think it's an unusual choice. Let's do this. I don't think this battery connects back. I think it's connected to the net alias. So yeah, okay. Okay, it's starting to form, but it's a little bit complicated. Okay. So the question is, does the battery connect to this? I think no. I think it does not. And the reason it doesn't is because it connects to sort of a virtual power source that we're going to put at the top. Like power, yeah, power bottom. Because it's a bottom port. Has nothing to do with anything else. Whoops. Bottom box. I think I got to shoot off a quick message real quick. Other nice thing about the multi-monitor setup is notifications right on the side there. Inviting people to SF. Nice. Coordination. Okay, this is going to be bottom for a bottom box, and then the Y is going to be negated. And then we'll add our power. It's not called power here, it's called 3.3 volts, so maybe we'll be consistent with the name. 3v3. So my hunch is that you add a bunch of virtual ones and any component can go down to these, and you add them in and they're part of the layout engine, whether it goes up or down. Because you need the grounds to act like that anyway. So we're going to automatically add these, and we determine if they're, yeah. So we automatically add them, and then you do the layout, and then you basically remove them. They're not actually placed on the schematic. And I think that'll work really well, but that means we need to put a lot of 3.3 volts down. So these things are like at regular intervals, essentially. So let's add our first one here. You also kind of have to place them after the fact. Yeah, and so you should always go to the one that's nearest to you vertically. Let's just create a bunch of virtual ones at the same distances as the grounds. Cool. Yeah, all right. And they even have to be higher because of the way I've kind of modified the circuit to adapt it to what I think our layout capability will be. Even higher. Oy. Starting to get a little ugly. With the grounds, they do go up and down, so I think we can do the same thing with the voltages. So they'll adapt kind of like this. Yeah, and then we'll add one more. 7.5 would be the next point. Okay. That's probably enough. Okay. Yeah, this would be a pretty messy layout, but the second part I think will clean it up dramatically, and it'll be fine. This part, I'm pretty sure, because so much stuff will move up and stuff like that. It's not going to be as good as the SparkFun one, but I think it'll get really close. I think it'll be surprisingly close to a really well spaced schematic. And what I found is, like, when Prettier was introduced, people didn't like some of the elements of its code style, but then it adopted like crazy because it was consistent. And sometimes consistency is much nicer than having a perfect layout every time, because people used to care so much about, the tabs versus spaces debate was mostly, I think, that spaces people liked that you could align content perfectly sometimes, if you needed to. And I still think that's a really valid reason for spaces. Even because with Prettier, you can, alignment is, it's handled, but now it's just like not a thing you worry about. Alignment, it's just done for you. So I think spaces probably should win if it hasn't. See, talking about the deep problems. I'm talking about the real problems here. These are all called the same thing accidentally, so we'll close to. Oh, it's pretty confusing. It's called. I don't know what to call it. Call it V. V1, V2, V3, V4. It makes it look like they're separate sources, but I'm just gonna ignore that for now. And then somewhere we have, yeah, right there. So we'll change this to V2 or V3. So that's probably the closest one. It's probably the closest behind you. That's probably the right way to do this. Okay. Cool. We're getting closer. Yep. Okay. Let's finish connecting the bug. So U1, G3, 2 is not connected. VCC USB. I guess in this case it connects to power. That's interesting. So we'll have that connect to V. It's a little weird. If you have a direct connection, I think you do go to the first one. And so likewise with port 1. Okay, so that's connected up. Learned a lot about this algorithm by doing it manually. Still unclear if we'll be able to finish today, because if it takes this long to manually do, how long is it going to take to automatically do? Let's add a connection for C6. C6. It's going to be so cool, though, when it starts pumping out like massive schematics and it just works, because all of this takes a ton of time. People to route, humans are doing this. Think of the humans. Okay, G3. Whoops, did I do this wrong? G3.top. Okay. And then all of these C5s just connect to power. It's kind of funny because in this particular case, it's not even really related to this U1. But in our case, since we're doing, people tend to group things together, and there's actually a group element, they would be included in the same subcircuit. So Luckily, we don't have to automatically group things. Figure out what components are relevant to the resistor or the central component. Okay, so C5 top goes to, let's say, V3. Actually, it's good for V4, C4, V4, C3, V5, and then C2, V5, and we should be done, I think. Not found, V4. Did I skip? V4 is right there. Oh, it's V4 dot bottom for all of these. Whoops. Okay. Okay, V3 isn't used. That's fine. Let's just remove it maybe, just to avoid clutter. Okay, cool. So this, if it lays it out like this, that is incredible. And then if we can simplify it, move things around by aligning things with that second post-processing step, that's amazing. I think this is really good. This is a great starting point for the problem. This object has built out a big old JSON object for us to use. So yeah, pretty good place. Let's commit it. Yeah, starting point for algo. So this is what happens now. Storybook's still running. The algorithm's going to be really complicated. There's going to be a lot of sub problems. I'm probably going to have to make smaller versions of the circuit, but what I'm going to try to do is do it all in one go. And if it all works in one go, we're in a really good place. But if it doesn't all work in one go, we have to build subcircuits to debug and stuff like that. So we attempt the fast route. If the fast route fails, we go to the slower routes. So let's get into it. Nothing to it but to do it. All right. So we're throwing away all the X and Y positions inside the algorithm. And we recompute. I don't really have enough room with Storybook to make a side-by-side to show this and that side-by-side. What I'm going to do is put our bug down here. This is our new source of truth. And I'm going to create a new story and show that story up here with our layout algorithm running in real time. So we'll create a second story, bug2.stories.tsx. Let me adjust this a little bit. Yeah. Perf. I like how I'm just fading out of existence. Let me tweak this more. Good enough for comedy. There we go. All right. I think I might attempt like sort of a morning and night stream. So I think what I'll do is maybe do 9 to 11, something like that, my time. I don't care about your times. 9 to 11 my time, and then something like 5 to like 7 my time. So some late time. Because my friends in the US are like, we're working. I'm I'm not gonna stop my work day to watch you struggle with negating numbers. Okay, let's change this to bug 2. Okay, so these are different. And we're going to create a library method, create a whole folder for it. So I'll create an algorithms folder, and then we'll say got to name it. I wonder if I should do the post-processing steps first, because I could also do that part, and that would be fine. I could also do it separately. It'd be interesting to know how that works. I don't know. I'm going to call it ascending central LR bug 1. Ascending central LR bug. All right, let's see. Cool. It's really nice to define a type for algorithms. So let's say layout algorithm is equal to a function that takes a scene and outputs a scene. And then we can type this as layout algorithm. And all we're doing is moving the boxes. Let's start by resetting. So to do remove reset and prod. Oh, also the X and Y positions, I guess, won't be needed for the layout algorithm. So the scene definition isn't totally correct, but we'll fix that later. Call this new boxes equals, we'll just do a very hacky deep clone of boxes for now. So new boxes is JSON stringify scene.boxes. This guy needs to take a scene. JSON.parse. So we're just doing a deep clone so that we can mutate them. And then I'll return box, scene, boxes, new boxes. Now I can go through each box and zero it out. So for box of boxes, box.x, box.y, 0. So let's call this on our scene. After we import it. And everything is zeroed. So that's our starting point. And we want to recreate something like this. Structure done. It would be nice to animate this so that it was understandable, but ain't nobody got time for that. So we'll see. I think it's simple enough where I don't need to animate it. I was going to start with simpler algorithms because there's also like just simple row and column algorithms and stuff like that. But that's less fun. It doesn't tackle as many risks, stuff like that. So I'm going to start with the big one. Okay. Step 1, identify central bug. And this is just the thing with the most ports. So center bug equals, or center box. We want to find the box with the highest number. Let's do a quick utility method. Find max. We could do find max box as its own thing. I don't want it to take up too much room in the algorithm because it's pretty simple. Yeah, array of box. It's not width. It's not about width. It's about ports. It's actually about the length of the ports. So whatever has the most ports becomes the center box. Otherwise, the first to find. So find max box, or find, it's kind of a bad name. Find box with most ports. So now we have our center box. It would be cool. We can call this an array of box, but we can also add maybe some subproperties to it. So we'll say for each box, we want to know the side. And then the ascending port index, which is basically how high from the bottom. How high from the bottom with port connections. Yeah, that's it. With regard to port connections. C3, C2, C3, C4, C5, they don't have any connection to they don't have any direct connection here. They have a connection through the net, but otherwise they don't have any connection. For any component like that, they just switch to their normal order. However they are defined. That's how I want to do it. I think it's simplest. So let's go ahead and label that for each box. Say box S side equals left. We'll put a to-do in there. We're just doing the left side right now. Box dot ascending port index equals. And now we have to go through the ports and figure out how high from the bottom it is. Oh, actually, you do this after you have the center box, now that I think about it. So label or get the ascending order of the boxes. Let's say ascending indices of the boxes. For a box of new boxes. So we'll say relevant side ports, because what's going to happen in the future to do. We should really label the ports on the center box. So we'll say that this is a box with we'll say it has custom ports where each of the port has its side index. A side should be left and side index number. Side ascending index. So each port has an ascending index. You find the port you're connected to. And then you have your, yeah, I think, is that enough to give you your ascending index? I think it is. If you have two ports that are, you might have two components that are tied for the same port. In that case, it would be in the defined order. So ascending port index is not the same as the, you can have ascending port index. Yeah, all right, fine. We'll make it the same for now. The tie thing we'll deal with. It's not hard, but we might want a second index that deals with it. It'll be so funny if this works first try. It won't. Ascending port index. So relevant side ports to do so only use ports on same side as box. So we're running the left and right at the same time. You can almost run them independently. They're basically two separate algorithms, but running them together might be a mistake. Box ascending port index is the sorry, I'm getting a lot of messages. Let's see. What is going on in the world? Oh, nice. Okay, cool. Just life things. Flux AI just released design reviews. Flux Copilot, engineering team superpowers with design reviews, PCB design reviews. It's pretty cool. Check all the pins that are correctly powered or grounded. Yeah, it's pretty cool. Yeah, I think Flux is way ahead of anybody else with regard to AI. It's pretty crazy. For circuit design. I'm like, I really want to work with Flux. Because they're kind of like my favorite of the graphical tooling as far as what they're trying to do. They're web-based, they're closest, I think. And there's stuff like JetX and Autopile, but they're not I don't know, I feel like they don't go far enough up the stack. I'm still rooting for them to ultimately it's like going to be a really, really big space, and so it can fit a lot of people. But Flux is pretty cool because I think it's a really fun product. So hopefully TS Circuit does some integrations. It'd be awesome if we could do open in Flux and stuff like that. And their AI is going to be better at a bunch of stuff just because they're building the model completely differently. I don't think people are building it the same way I'm building it. Maybe, I don't know, but okay. Subproblems to solve. Relevant side ports. Man, I wish this was like, I wish AI could build this out for me. It's just so time consuming. But anyway, it's fine. At least it's like a fun problem. Relevant side ports. Box.ports. Box ascending port index. So, I'm iterating over the boxes here, but really we should be iterating over the ports. So let's say const side of left, right. If side is equal to right, we're just going to continue to do if, and then we'll say const side ports equals center box dot ports to do again. And then we want to, for each port, so we're iterating through these ports. Oh, it's kind of, okay. All right. I'm a couple steps behind here. Yeah, catch you later. See ya. Thanks for stopping in. I tune you out on the second screen. as is expected. I wouldn't have it any other way. Side ports. Sort. I think that's fine. I don't know if this is ascending order. I think it should be. And it's okay we're doing a mutating sort because this array will be filtered in practice to a new array, or once the right side is done. Side ports that sort, and then for const port of side ports, ascending port index, we're going to call it index of ports. Okay. So yeah, it's whatever you're connected to determines your ascending port index. It's not too complicated. Of new boxes. Ports box is connected to. How do I get this? I have to go through the scene connections and find any that contain the box. Go through the scene connections, any that contain the box. Box connections. And then we want to map it to, so if the front, yeah, so this is a little, we can say like from dot includes box ID dot, or starts with. That's like an efficient way to do it. If it starts with box ID, plus a dot, that'll make it safe. If it starts with this, and then this needs to be box ID, or 2 starts with box ID. And then this is the annoying part. Yeah, exactly. So you want to get, if from starts with it, then you want to get the 2. Otherwise, you want to get the from. And so now we know everything that's connected to the box. I need noise canceling sometimes, but silent headphones don't cut it. Yeah. Noise canceling, a really lightweight pair of noise canceling headphones. I have the AirPod Maxes and I kind of regret it because it's so heavy. I think a really lightweight pair of headphones can be really great for just kind of focusing in. It's also a great signaler because I have AirPods in and people try to talk to me all the time. Much easier to have headphones on and just signal to everybody that, yeah, I'm doing a thing. You can't expect me to hear. Right? Yeah, people will try to chat with you with AirPods because it's just become like part of how we live, is we sometimes always have AirPods in. Okay. So now that we have the box connections, we should be able to derive what ports the box is connected to. Let's do that. You know what's interesting too is you can have a component that's connected on both sides. So that'll be an interesting tiebreaker. Hey.
Hey, I'm gonna... See ya.
Girlfriend just told me she doesn't love me.
Fuck.
She was like, eat dinner alone. No, I was just messing around. All right, anyway. Box connections, ports, boxes connected to. Let's see. Center box dot ports. Filter ports where port ID is equal to box connect. No, it's box connections includes. Okay. Yeah, I should probably use better data structures for networks. It's just annoying because you're either verbose or you're compressed, and like none of it matches regular databases with rows and stuff like that, and not having stuff duplicated. So after you have the ports, and each port has an ascending port index, what you can do is give the box its ascending port index by taking the minimum, so it's first connected to, for each of these ports, ascending index. It's not respecting our type, which is fine. Side ascending. So it's not respecting our type because I think centerbox.ports, centerbox, I don't know why it's not respecting our type. Side ascending index, I don't know. Ports, boxes connected to. I think it should respect our types. I don't know. Centerbox.ports. I guess this merge operator isn't doing, I could do omit. Excuse me, I could do omit ports. Yeah, seems good enough. Oh, it should be, yeah, look at that. Maybe I keep the name consistent. I kind of varied the name a little bit. It's just always have it be ascending port index. Okay. So we can already start to lay out if we just set the box's Y position to that ascending port index. That's the first stage. It just goes up. So we could do that. Box.y is equal to box.ascending port index times 1. It's also negative, and then it's like plus 3 or something like that. No, actually it's -3, and then it's positive. Okay. And then the center box didn't like that, so we'll just say if box is equal to center box, continue. If ports box is connected to dot length is equal to 0, we'll skip those as well. Oops. Nice. So we're starting to get a layout. These guys didn't get laid out because they're not connected, which is fine. That's expected. They're going to get laid out when we do basically when we say anything else. So actually we could do it here. If you're not connected to anything else. This is where this is where you get the difference between ascending port index and then ascending box index is what I would say. So we can introduce that. So we have ascending how high from the bottom this box should be ordered. Ascending box index. So if you have an ascending port index, it's the same. is equal to ascending port index. And we gotta change a lot of stuff now. So box of new boxes. And let's see, highest ascending box index is math.max. Yep. And for box if box dot has box, yeah, exactly. Okay, cool. And now we can set the Y positions. Took a second, but we're ready to do it. Is equal ascending box index. We're going to skip the center box again for all of these. If box is equal to center box, continue. And this is going to get more complicated when there's two sides, but for now it's fine. It appears to be unintentional because we can, is it the same up here? Okay, so we'll say, so it works, but for some reason it doesn't check out. So we'll just change it to this version that uses IDs. Okay. And we can also set the X position. The X is -1 minus ascending box index. Nice. So there's something here. Interestingly, it mapped G1. Also, I guess I was pretty anal about that being like -1.5. Okay. Yeah, it's good. So interesting thing happened here where these are connected to the same one. And so the ascending box index really should be 1 here. I think that I might solve that in post-processing rather than right away. Also, all of these got lumped together. So that's not right. It should be higher and have more. Highest, blah, blah, blah. If box ascending box index. Just for funsies. Actually, I don't know. Highest ascending box index. If, let's log out. I'm really confused what's happening here. New boxes, highest ascending box index. It's not a complicated operation. Oh, highest ascending box interest. Oh, okay. So we'll just filter, make sure these are defined. Box index, I think I can say is number or not is not a number. Okay, there we go. So it's getting quite high. And part of that is because all these V5s, V4s, stuff like that, the grounds, those are not really supposed to be there. Those are going to be added virtually. Probably what will happen is there'll be... I got to think about this for 1 second. I think they should, at the very least, be excluded from this part. I think there's an explicit net alias like this one, and that one you have to keep. But for others, you don't keep them. And they might even be added after. So, yeah, let's, for now, remove everything but GU1. So if a user adds them explicitly, you keep them, but otherwise we're going to remove them. And then we have to remove everything that was related to that. Oy. Box not found. I don't want to lose all those nice connections, though. Let's make this guy not error if you have an undefined connection. That's going to be in the lines canvas. I think it throws an error. Yeah. So instead of throwing an error, it is nice to have little errors. I think I'll change it to, I'll leave some ghost code. I'll say return null. We'll comment this out. We'll have this thing be allowed to return null. And then if A is equal null or B is equal null, we will continue. Yeah, just for now. Okay, so this is right. So one thing is this -3 is set explicitly. It's actually supposed to center. So after you lay out all these boxes, you can try to center the left side. Lost my algorithm. It doesn't really, I guess for our purposes, the centering doesn't really matter right now because this part, you run this part and then you recenter. So I think centering is going to be another post-processing step. I don't think it's particularly important. Yeah. Okay. Oh, we still have all the, no. Okay, cool. Is that it? I think the post process, I think we might have done it. The post processor takes care of the rest. So that's it, I think. For at least for just left side. That's good. That's left side auto layout. There's definitely, yeah, I think we have to run the post process step. So for the post process step, we need to add additional information to the scene. I think we need to add the net. I just think we need a net. And then I think we also need to know if the net is like ground or power. Maybe not, but because you could do a thing where power doesn't always have to go up. I think it'd be best practice too, but could do that. This configuration, I just realized that we're emulating, it doesn't have a pull-up resistor, which is a pretty cool little thing. This one too, they don't have pull-up resistors. I would love to be able to have that not look jank. It might be okay. But I think we're done with this stage of the algorithm. The post process will bring all of these up. It'll bring these two down. And it should be fine. It should just work. Okay, so it's 11. So I'm going to take a break, and I'll be back online later. Maybe I'll do a little bit of work on this algorithm in the meantime, but it's time for yoga. It's time to get my yoga on. So appreciate for those who tuning in.